Hello friends, this is Durga again from IT University, and as part of this video I will be covering how we can actually copy data to S3 and also the job file to S3, and we will see how this can be used while running the MapReduce job in the AWS EMR Hadoop cluster. I might not run the job in this video, but I will do all the prerequisites that are required to run the job, and then as part of the subsequent videos we will see how it can be run and how we can actually troubleshoot it. So first I am going to S3. I will create a new bucket and then I will show you how to copy the data effectively into S3. So let me create a new bucket with the name NYSE, and you can have region anywhere. S3 is cloud, and you can have it in anywhere. But if you want to run on a particular region, you can choose Oregon or Northern California or other ones. I'm just using US standard for this, and then I am creating the bucket. Okay, it is already there, so I have to name it as IT University to make it unique and create it. So the bucket is created, and now you can go to your terminal and you can run commands using AWS S3 command line utility from the command line also. So whatever you can do using the web interface, you can do it from the console also. So let me show you first what we can do using web interface. So now we are in the NYSE IT University bucket, and I would like to create folders, one for input of the data and the other for jar files, where I will be copying the jar file which have the code, and the third one is output, where I will point my output location when I run Hadoop MapReduce jobs using AWS EMR. So once you have that, you can click on jar file, you can click on the directory and you can upload the files using actions button, and in that there is a create folder action which we have seen to create the folder, and you can upload the files from here. You can click on upload, and if you want to do bulk upload, you have to click on this enable enhanced uploader. It has some issues on my Mac, so I will not be using that, but jar file will be typically one or few files, so I will directly use add files. But when it comes to data, you can use enable enhanced uploader, and it will facilitate you to upload bulk files in one shot. You can upload the directories and all those things. But when you use add files, you can only upload the files. You cannot upload the directories. If you want to upload the directories, you have to enable enhanced uploader, and you have to use a Java-based web interface to upload directories in bulk, which I will not be doing as part of this video because I have some issues when I try to use with my Mac on my Safari browser. That being said, click on add files, and you have to go to the jar where the jar is created, and if you are following my MapReduce application development playlist in my YouTube channel, I have the code in on my PC, and the same code is already shared on my GitHub account also. So let me show my GitHub account. You can go to my GitHub account and go to my repositories, which are here, code, and you can actually set up on your PC, compile it into a jar file, and you can upload it into the jar. You can upload into S3 bucket, so that the jar file can be used to invoke the MapReduce program to process our data, which will be in S3. Okay, so the code is available here, and if you want to understand what is there in the code and all, I will refer you to another playlist on my channel, which is called as Hadoop MapReduce application development using Java. and it has explanation of almost all the MapReduce APIs. And also I have taken some case studies on New York Stock Exchange data to demonstrate all those different APIs to develop good MapReduce based applications. So you can follow this to understand further. But if you want to run this jar file as is, I'm showing to you, what you have to do is you have to download this code and set up on your PC using Maven, compile it and build the jar file and pass that jar location when you try to upload the file here. In this case, the jar location is code NYSE target, and this is the jar file which I am uploading, and click on start upload. It will be uploaded in a minute. Once the jar file is uploaded, we have to copy the data into the input path. So using the code that is there in this jar file, we will be processing the data that will be copied to input. For now, input is the empty directory, and if I try to upload the files by clicking add files, I can only upload. I can only upload the files. I cannot upload the data directories, and the data is in this directory NYSE and raw data. And if you want to get this data, again you can go to my GitHub repository, and in this, if you go to my home page, there is a repository for the data. You can click on that, and there is a directory for NYSE, but the data is uploaded in the form of tarball zipped by gzip. So you have to download this and run tar xzf command to untar into a directory on your PC, and you should use this to upload if you want to run my code base against this data set. So that being said, but in this case I cannot upload the directory. Only when I choose the file, the choose button will be enabled. So it is not a very effective way of uploading these hundreds of files into S3 so that data can be processed using the MapReduce code which is there as part of the jar file. So I'm cancelling it. If you want, you can enable enhanced uploader, and then you can actually upload the entire directory in one shot, which is pointing to raw data. But more than that, there is a command line way also, which I will show you now. Okay, so to run that, you need to actually set two environment variables, either in .profile or using export command. Okay, and they are, so these two are the parameters, access key ID and AWS secret access key, which you need to set, and you have to export with the values which you will get, which you would have got when you actually sign up to the account. Again, if you want to get the details about how you can get these two things, you can go to my video in Amazon Web Services playlist, and you can get the details about access key and secret access key. And when it comes to S3, I have shown you exactly how it can be done. Okay, so let me set those parameters. I don't want to share my access key and secret access key at this time. There will be values associated with these two things which you need to set properly so that you can actually access your S3 bucket. So now I have exported both AWS access key ID and also AWS secret access key. Now I can run AWS command. AWS have many sub commands. One of them is S3. As we are dealing with S3, we can use S3 command, and then you can do ls and hit enter, and it will return the directories you have on your S3 bucket, S3 account. So we have 3 buckets. One is for the logs which I have run before, and this is the one which I have created earlier, and this is the one which I have created just now. And if you want to navigate through those, you can actually give the path like this and hit enter. You have to give the slash to see the contents under this directory, otherwise it will not show you the folders under this folder. Okay, if I just run this command, it will not return anything. You have to give this slash. Oh, it's working. Sometimes it does not work. Anyway, now you can use S3 protocol also. In some commands you have to give the S3 protocol, and hit enter, it will show you the contents of the directory in S3. Now we can also review what we have under the jar directory. See, now it is not showing up, but if I give slash at the end, it will show the jar file which we have copied using the web interface. So this slash is mandatory when it comes to subfolders, but at the higher level bucket, it seems you don't need to put that slash. Anyway, so now we have the jar file, and we want to see what is there in input, and you can see that there is nothing here because we haven't copied the data yet. Now we have to copy the data to here, and we have too many small files in this case, so we cannot copy one file at a time by using cp command by creating the directories. For that reason, we have to use this command called sync, where it will sync the source directory with the target directory in AWS. So the command will look like this: AWS S3 sync, and you have to give the local directory first. Tilde is the home directory on my local PC, slash I have my data set under research, big data, and data, nysc, raw data, and there are many subdirectories here. One of them is nysc underscore 2009, and I want to copy whatever is there in that to s3 colon slash slash nysc it slash input slash raw data slash nysc underscore 2009 and hit enter. So there are 260 files, and it will take a while to copy this data. So far it has copied 45 files, and there are 261 files in total. So we have to wait until this is done. And we have 6 such directories, one for each year. So if you go to my folder structure for my data, it is under USD, it's my home directory. In that there is a data directory, and in that there is nysc, sorry, it's under USD, it's under research, big data, data, nysc, raw data, and these are the 6 directories which we are trying to copy. And one directory we have copied. Either you can run one command at a time, like 2009, 2010, 2011, 2012, 2014, or you can directly sync up like this. Okay, but it will take a very long time because we have almost 1500 files. For that reason, I will just use NoHub for each of the year, and then I will try to spawn multiple threads. 2010, and I want to copy to nysc underscore 2010. Okay, and I want it to be running on the backend, and now it is running. You can validate by running tail -f nohub.out. So files are being copied. Control C. Now let us do the sync in parallel for the other years. So these things are running on the backend. Okay, now let me do 12. If you want, you can script these things also. That's why they have provided this command line interface. And you can monitor until it is done by running tail -f on nohub.out. Okay, so let us wait until the copy is done. Then we will see how we can use this input path and the jar file while creating the cluster, and then we will create the cluster and we will process the data as part of the Amazon by using Amazon EMR cluster. So all the files are copied. You can also review going to the web console for S3, and there is a refresh button here. You can click on this because we are already in the current input directory, and you can click on the raw data, and you can see all the 6 directories which have the files that needs to be processed. So we have all the files here. Now we have to use this data and use the jar file which is uploaded earlier, and try to process the data, process this data using the code that is part of the jar file. For that, you have to go back to the EMR. So click on this one to go to the main console, and then go to the analytics and click on the EMR console. And here you can actually click on create cluster to start creating the cluster. And to demonstrate this, we will be using step execution. So we will just run one job and terminate our cluster automatically. And I will show how we can actually troubleshoot the issues and all those things by running using step execution as part of this video. And as part of the latter videos, probably I will try to create a cluster and try to run a Hive job, so that to demonstrate how we can actually create the cluster and then run multiple jobs when the cluster is up and running. But for now, we will be using step execution. And as I have explained earlier video, step execution is to run one step or one particular MapReduce job and terminate the cluster once the job is done. Okay. So to demonstrate what I will be showing, I will show you the data I'm trying to process. So I'm going to the location on my PC from where I have copied the data, and there are 6 directories for each year, means 1 directory for each year. So there is 5 years worth of data starting from 2009 middle to 2014 middle. That's why you can see 6 directories here. I'll be going to one of the directories, 2012, and ls-ltr, and there are many files. So there is a directory for each year, and now there is a file for each day. So this represents the date, YYYYMMDD format. So the first 4 digits is year, and then 5th and 6th digits are month, and last 2 digits are date. So you can look at the data set, and the data set will give you end of day information about each and every stock for that day. So the first one is stock ticker, and the second field is data is delimited by comma. First field is stock ticker, second field is transaction date, which is 4th of January 2012, which is 2012-0104, and then there are 4 prices here. One is open price, second one is high price, third one is low price, and fourth one is closing price, and then the last one is volume. And using this data set, what this program which I will be running is top 3 stocks by volume per day will give what are the top 3 stocks traded by volume. So for the day of 4th January, you will see 3 stocks which are traded, which have the highest volume traded for that day, and we will try to get top 3 stocks as part of this code. If you want to understand the code base, again, go to my Hadoop MapReduce application development playlist, and you will. I have shown you how to develop end-to-end MapReduce application using different APIs as part of the videos, and the code is already shared in GitHub. You can take it from there and you can run it against the dataset, and dataset is also available in GitHub. So we will be running this program against this data to get the top 3 stocks that are traded on each day by volume. Okay, so let's go back to the AWS EMR web console. Here we are choosing step execution, and we have to choose what type of step we want to execute. It can take a Hive program, pig program, and if you want to run a custom MapReduce program, you have to use custom jars for that. And once you choose this configure button will be enabled. You can click on this, and then you can name it whatever you want. Let me name it as top 3 stocks by volume per day, and we have to choose the jar location. That jar location is in so the jar file should be in S3. That's why we have copied the jar file to S3, and it is under NYSE IT Varsity, and there is a jar file here. You can choose the jar file and click on select, and now it is pointing to the jar location. And then we have to pass arguments like you do in Hadoop jar command. If you are new to Hadoop, again go back to my Hadoop MapReduce application. If you are already familiar with Hadoop, you have to avoid Hadoop jar and jar file, because that is already taken care, and then you have to pass the rest of the arguments. In this case, this program takes 3 parameters. One is input path, second one is a regular expression of the years, and the third one is the output path. And also we have to pass the MapReduce program as the parameter. So total it takes 4 parameters. First parameter will be the Java class name with the package name dot, this is the MapReduce application we want to run, and the second parameter is the input path. As we are using S3 and Hadoop is capable of reading data from S3, you can give S3 path directly here, and our bucket name is NYSE IT Varsity. And then you have NYSE IT Varsity input raw data. So we have to give the base directory for our data set. Let me give that NYSE IT Varsity input and then raw underscore data. Okay, and so that is the base directory for our data set. And then I have to I hit a space, it is not showing up here. I have to give NYSE underscore regular expression. I want to only get the top 3 stocks for year 2012 and 2013. So I can give 2, 3 because I want to process only 2012 and 2013 data and eliminate the other ones. And then I have to give the output path. Output path is again NYSE IT Varsity / output and / you have to give a unique directory which do not already exist. So we cannot just give NYSE Varsity NYSE IT Varsity and output. We have to give subdirectory to that. So let me give top 3 stocks. Okay, and then you can click on add, and action on failure there are 3 events. One is continue, which will actually terminate the cluster even on failure. In some cases it might not terminate the cluster depending upon a type of event. Cancel and wait, if there is a failure in the job, it will just cancel and wait, so that you can take the necessary action to fix the issue and rerun the job. The reason is, if you terminate the cluster every time, the pricing will be done on hourly basis. So even if you use each of the instance only for a minute in 1 hour, it will be charged for the whole hour. So when you actually start exploring for the first time, I will highly recommend to use cancel and wait. Make sure there are no issues for your jobs, and make sure you are comfortable with the overall process, and then only terminate the cluster. But if you are already familiar, you can either leave it as continue, or you can choose terminate the cluster if it fails, depending upon what you want to do. So in this case I am using continue, but if you are running for the first time, I will highly recommend to use cancel and wait. It will save some money for you. And click on add. Now it is pointing to the jar file and the input path, and you can choose whether you want to use MapR distribution or Amazon, and you can choose whatever instance types you want, and then Also, if you want to have a standard name for your logs, you can give your standard name. But if you want to use the default naming convention which it creates, you can use that one here. In this case, I want to create a standard location under NYSE IT University itself. So I will create a new folder for my logs. Okay, and then I will click on this one, NYSE IT University, click on logs, and say select. And probably you might have to give the unique name. Let's see how it works. I never used this custom names before, but this is the first time I'm trying to use. Let's see what will happen. So you can set all the configurations starting from the log files, what you want to do, whether you want to create a cluster or step execution just to run one thing. Once you choose the step execution, it will ask you to configure your jar. First, it will ask you to choose the step type, and depending upon the step type, it will ask you to choose the jar location and the arguments. If it is custom jar, if it is high, the configuration will be different. We will see those things in future, but for custom jar, these two are the important things: jar file and the arguments about your MapReduce application, input path and output path. And then you can choose the vendor, Amazon or MapR. You can choose the instance type here. I will be using m3.xlarge, and you can choose number of instances, whether you want to use one instance or 3 instances. In this case, I will just use two instances, one master and one core, to create the cluster and run my MapReduce job. That I will take care as part of the next video. For now, that is it. In this video, we have covered how we can actually copy all the relevant resources before creating our AWS Elastic MapReduce cluster using step execution feature to execute one MapReduce job to process our data. That being said, I hope you are enjoying the content on this playlist as well as on my channel. If you like this video, please click on the like button. If you have any questions or if you want to provide the feedback, please use the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.